I want to show you something. This is a photograph of a farmhouse in Lancaster County, Pennsylvania. Built in 1821. The walls are white. Not white like a house that was painted last spring. White like a house that has been white for 200 years. The same application, the same finish, the same wall. Nobody repainted it, not once. I know that because I tracked down the deed. I found the maintenance logs, and I found something that stopped me cold. A single line written in 1823. 2 years after the house was built. It said, lime coat applied. Final. Final. 200 years ago, a builder wrote the word final on a wall treatment. And he was right. My name is James Merritt. I spent 30 years in construction. I've watched paint peel, bubble, crack, and choke off walls on a schedule so reliable you could set a calendar to it. 3 years for cheap latex, 5 to 7 for premium, maybe 10 if you paid a contractor who knew what he was doing. And used a product that cost 4 times more per gallon. I replaced paint the same way I replaced fence posts, on a schedule without ever asking why. I should have asked why. The problem with modern paint. Here is something the paint industry will never put on a label. Every gallon of latex paint you buy is designed to fail. Not because the chemists are incompetent, because the business model requires it. A coating that lasts 200 years cannot be sold twice. A coating that needs replacing every 5 to 7 years. That is a product with a future. The global paint and coatings market generates over $160 billion per year. It is sustained by one operational assumption, that you will come back, that the wall will need repainting, that what you bought last time wore out as it was designed to do. Modern latex paint works by forming a film on the surface of the wall, a thin, flexible polymer membrane that sits on top of the substrate, on top of the brick, the plaster, the stone, the wood. That film expands and contracts with temperature. It absorbs moisture and releases it. And every single cycle, every summer, every winter, every rain, stresses the bond between the film and the wall. After enough cycles, the bond breaks, the paint peels, the wall chokes. You go back to the hardware store. This is not a flaw in the product, it is the product. Now let me tell you what lime wash actually does, because it is the opposite of everything I just described, in every important way. Lime wash does not form a film on the surface of the wall. It becomes the wall. When you apply slaked lime to masonry, to brick, stone, plaster, stucco, concrete block, a chemical reaction begins. The calcium hydroxide in the lime reacts with carbon dioxide in the air through a process called carbonation. It slowly converts back into calcium carbonate, the same mineral that makes up limestone, marble, and the shells of marine organisms. The wall is not coated, it is mineralized. The lime does not sit on top of the substrate. It bonds into it at the molecular level, forming a crystalline calcium carbonate layer that is chemically identical to the stone it was applied to. You cannot peel a chemical bond. You cannot scrape off a mineralization. There is no film to crack, because there is no film, only wall. That is why that farmhouse in Lancaster County has not been repainted in 200 years. That is why Roman aqueducts built 2000 years ago still carry traces of their original lime coating. That is why medieval churches across Europe, standing for 800 years through frost and rain and war, still show their original lime finish on interior walls. The chemistry has not changed. The raw materials have not changed. The only thing that changed was the market. The history they buried. The use of lime as a building material is older than recorded history. Archaeologists excavating the site of Çatalhöyük in modern-day Turkey, one of the oldest known human settlements on Earth, dating to approximately 7500 BCE, found lime plaster on the walls and floors of dwellings. 9500 years ago, people were processing limestone, burning it, slaking it with water, and applying it to walls. They understood something that took us until the 20th century to forget. In ancient Egypt, lime was used to protect and decorate the interior walls of tombs, chambers that were sealed for 3000 years and open to find the finish still intact, still white, still bonded to the stone. The Romans systematized lime production on an industrial scale. Vitruvius, the Roman architect and engineer who wrote De Architectura around 30 BCE, the oldest surviving complete work on architecture, devoted an entire section to the correct preparation and application of lime plaster. He specified 3 coats minimum. He described the correct ratio of lime to aggregate. He noted that lime becomes stronger with age, that a wall treated with lime in the first year is better in the 10th year than it was in the first. He was describing carbonation. He did not have the word for the chemistry, but he had the observation, and he wrote it down. The Islamic world carried the knowledge forward. The intricate lime plaster decoration of the Alhambra in Granada, Spain, built in the 13th and 14th centuries, has survived 700 years of Mediterranean weather. The craftsmen who built it used a technique called tadilakt, a polished lime plaster mixed with soap to create a waterproof surface, so dense that water beads off it. This was not primitive, this was engineering. In Northern Europe, lime wash was the universal exterior finish for stone and timber frame buildings from the medieval period through the 19th century. The famous white farmhouses of Scandinavia, the ones you've seen in photographs, the ones that seem almost luminous against dark winter skies, those are lime washed. Not painted, lime washed. Some of those buildings have been maintained with annual thin coats of lime water for 400 years. The finish is self-repairing. Each new coat bonds into the previous one, adding depth and density over time rather than peeling away. In Britain, the tradition of lime washing buildings was so universal that the phrase whitewashing, meaning to cover up a problem, entered the language as a metaphor. But the original practice was not about covering up. It was about building something that lasted. The Mennonite and Amish communities who settled Lancaster County in the early 18th century brought this knowledge with them directly from Switzerland and Germany. They applied it to every building on every farm. The farmhouse I showed you at the beginning of this video, built in 1821, lime coat applied. Final was built by people who had been lime washing buildings for 10 generations before they ever crossed the Atlantic. And then in the 1940s and 1950s, it stopped. Not because lime wash failed, not because something better was invented, because something cheaper to manufacture was developed, given a compelling marketing campaign, placed on hardware store shelves, and sold with the implicit promise that modern chemistry had improved on 2000 years of accumulated knowledge. It had not. What happened was simpler than a conspiracy and more corrosive than one. Portland cement became cheap. Latex binders became cheap. Titanium dioxide, the white pigment in modern paint, became cheap. The industrial supply chain for synthetic paint was built, and it was profitable, and it required a customer base that believed they needed to repaint walls every 5 to 7 years. Lime wash has no supply chain to protect. You cannot patent slaked lime. You cannot hold intellectual property over calcium carbonate. There is no proprietary molecule, no trade secret, no licensing revenue. So it disappeared from the hardware store shelf. And within 1 generation, the knowledge stopped being passed down. And within 2 generations, a homeowner staring at peeling paint on a 100-year-old brick house had never heard the word lime wash spoken aloud. Until now. The formula. The formula has 2 ingredients: slaked lime calcium hydroxide, also called hydrated lime or builder's lime, and water. That is it. For a basic lime wash that will protect and color masonry walls, you mix 1 part slaked lime to 4 to 6 parts water. Stir thoroughly until it has the consistency of thin milk, no lumps, fully dispersed. That is your base lime wash. 1 5-kilogram bag of hydrated lime costs approximately $3 to $5 at a builder supply merchant. It will make enough lime wash to cover 200 to 300 square feet of wall in a single coat. The cost per square foot works out to somewhere between 1 and 2 cents. 1 to 2 cents per square foot. A professional exterior paint job on a brick house runs between $3 and $5 per square foot for a product that will need redoing in 5 to 7 years. The math does not require a spreadsheet. Now, the base formula is functional, But there are two additions that traditional builders used to extend performance and add specific properties, and both of them are documented in sources going back centuries. The first addition is salt. Common table salt, sodium chloride, added at a ratio of approximately 100 grams per liter of lime wash. Salt was used by builders across Europe and the American colonies for one specific purpose. It slows the carbonation process. A lime wash without salt dries very fast in warm weather, which means it can dry before it fully bonds to the substrate. Salt gives you working time. It also increases the hardness and weather resistance of the final cured surface. The Mennonite farm records I've referenced before, those Lancaster County agricultural diaries from the 1800s, specify salt in every exterior lime wash entry. Not sometimes, every time. It was not optional. It was understood to be part of the formula. The second addition is alum potassium aluminum sulfate, which you can find at a pharmacy or from beer-making suppliers. Add approximately 50 grams per liter of lime wash. Alum acts as a fixative. It reacts with the calcium in the lime to form additional mineral compounds that increase adhesion, reduce dusting, and dramatically improve water resistance on smooth or semi-smooth surfaces. Traditional Tadilact, the polished lime plaster of Moroccan and Andalusian craftsmen, used alum as a key component. The combination of lime and alum creates a surface that is genuinely waterproof. Shower walls in traditional Moroccan riads have been finished with Tadilact for centuries. No tiles, no grout, no silicone sealant. A mineralized surface that water runs off like glass. The complete formula for exterior lime wash. 5 kilograms of hydrated lime, 20 to 25 liters of water, 100 grams of salt per liter, 50 grams of alum per liter. Mix the lime into the water slowly, stirring constantly. Add the salt and alum after the lime is fully dispersed. Let the mixture sit for 24 hours before application. Stir again before use. Application requires a natural bristle brush, not synthetic. The bristles need to be stiff enough to work the lime into the surface texture of the masonry. Apply in thin coats. This is important. Thick application does not give you a better result. It gives you a coat that carbonates on the outside before the inside has cured, trapping uncarbonated lime beneath the surface. Thin coats, multiple passes. Let each coat dry completely before the next. 3 thin coats will give you a surface of exceptional durability. 4 coats will give you something that, if properly maintained, will outlast everyone alive today. For maintenance, you do not repaint. You apply a single thin coat of lime, water, pure lime and water, no salt or alum needed. Every 3 to 5 years. Each maintenance coat bonds into the previous one. The wall gets better with time. More dense, more mineral, more durable. After 50 years of maintenance coats, you have a wall with 50 layers of calcium carbonate bonded into the substrate. It is by that point essentially the same thing as the stone it was applied to. That is what the builder in 1821 understood when he wrote the word final. The suppression. In 2003, I mentioned earlier, the EPA forced the residential lumber treatment industry to stop using arsenic-based compounds on wood sold for home use. They had been treating the wood in children's playgrounds with a substance containing arsenic for decades. It required regulatory intervention to stop it. The builders who used lime had never needed that intervention. Lime is not toxic. It is alkaline caustic in concentrated form, which means you wear gloves and eye protection during mixing, the same precaution you take with baking soda at high concentration. Once cured, calcium carbonate is completely inert. It is the same compound as chalk, as eggshells, as the mineral in your bones. In 1974, the National Trust for Historic Preservation in the United States published guidelines recommending lime-based mortars and coatings for historic masonry buildings. They noted that Portland cement, the material that replaced lime in most 20th century construction, is actually too hard and too impermeable for use on older buildings. When you repoint an 1880s brick wall with Portland cement mortar, the mortar is harder than the brick. Moisture that gets into the wall cannot escape through the mortar. It escapes through the brick, which then spalls and cracks. Restorers spend tens of thousands of dollars undoing Portland cement repairs on historic buildings every year. The lime was not wrong. The lime was correct. What replaced it created the damage that now costs a fortune to repair. The Society for the Protection of Ancient Buildings, founded in England in 1877 by William Morris, has published guidance on traditional lime techniques continuously for nearly 150 years. There are technical pamphlets freely available describe in precise detail the formulas and application methods that were standard practice before Portland cement replaced them. None of this is secret, none of it is hidden. It is freely available to anyone who looks. The knowledge was not destroyed, it was simply never advertised. And in a market where the advertising budget determines what homeowners know, not being advertised is functionally the same as being buried. The paint industry spends approximately $15 billion per year on marketing in the United States alone. Slaked lime has no marketing budget. It never has. It never will. That asymmetry, not a conspiracy, not a plot, just an asymmetry, is why you have repainted your walls 5 times since you bought your house, and why the farmhouse in Lancaster County has not been repainted since 1821. Close. Here is what I want you to do this weekend. Find the oldest masonry surface on your property. A brick wall, a stone foundation, a concrete block fence, an old plaster wall that someone covered with latex paint in 1987 and has been peeling ever since. Go to a builder supply merchant, not a big box hardware chain. A builder supply merchant. Ask for hydrated lime. You will pay between $3 and $5 for a bag that will cover more wall than you have. Add water, add salt, add alum if you can find it, and you can. Apply one thin coat. Then come back here and tell me what happened to the surface in the 30 minutes after you applied it. I already know what you're going to say, because it is the same thing I said, and the same thing every person says the first time they watch calcium hydroxide start its slow conversion back into stone. It looks like it's becoming part of the wall. That is because it is. The formula is not complicated enough to forget. A $5 bag of hydrated lime, water from your tap, salt from your kitchen, and a brush. That is what 200 years of durability costs. I've been finding things like this for 4 years now. The lime wash formula is one of 5 systems in what I've come to call the complete traditional building kit. The methods that were standard before the industry decided that standard should mean something you replace. The next one is about roofing, specifically about a technique for treating wood shingles that costs less than 2 cents per square foot, was documented in colonial American building records, and that the modern roofing industry, a $30 billion market, has worked very deliberately to keep off every guide that homeowners actually read. That story is coming. Stay close.